Hi everyone. In this video, I'm going to show you how to solve some of the problems in your homework, how we can sketch two complete cycles of these functions. So let's start with this one. In this function, we have 3 times sine of 5 theta. This number 3 is multiplied by the function, but it's outside the function. So it's similar to what we have like y equal to 3 sine of theta, and we learned before that this 3 is going to change the amplitude of the function. So we can say in the new function the amplitude is equal to 3. So by taking the number which is multiplied outside of your function, you can find the amplitude of the function. Then we have 5 times theta. This 5 is going to change the period of the function. How? To find the new period of this function, we're going to take the period of the parent function. We know that the parent function is y equal to sine of theta, and the period of the parent function is 360 because we're working with degrees. That's why we write 360. So we're going to take the period of the function of the parent function and divide that by this value, by 5. So I'm going to call this as A and this one as B. So we divide 360 by B. Okay, and then when we divide 360 by, that will be equal to 72. So 72 is the new period of this function. So first we found the amplitude, then period. Now we need to find the critical points. We said to find the critical points, we take the period of this new function and divide that by 4, because we know that there are 4 sections between the critical points. So this divided by 4 will be 18. Now we are ready to graph the function. So I'm going to start with the coordinate plane. Let me fix this for you. Okay. So the first thing that we need to do is to find the critical points on the coordinate plane. We know that we're going to start with 0. This is the first critical point. And this 18, as we know, is the distance between the critical points. Or in other words, I would say this 15 is the steps that we need to go from each critical point to the other one. So from 0, I'm going to go 18 to the right. That will be 18. This is the first critical point, and this one is the second critical point. Then another 18 added to this 18 will be 36. This is the second critical point. Again, I have to go 18 more after 360, and that will be 54. 18 added to 54 is 72. So this is one cycle of this function. Now we need to find the second cycle. I'm going to write that with another color so you know that this is the first cycle and now the next one is the second one. So add 18 to 72, it's 90. 18 to 90 is 108. 18 to this number, let's continue this line. 18 to this one will be 126, and then another 18 to 126, 144. So these 4 points are the critical points of the second cycle, and this one is for the first one. Then we need to find the amplitude of the function. We know that it's 3, so we're going to go up 3 from this point and down 3 from this point. Why do we go from this point? Because we know that this is the sinusoidal axis of the function. This line is the sinusoidal function, a sinusoidal axis of this function, y equal to 0. So to find amplitude, we need to go 3 up and 3 to the bottom of this line. Now we're ready to graph the function. We know that when we want to graph sine is always like this. So it starts with the middle point, then high, middle, low, and middle again. So we're going to do this, use the same pattern here. So the first point is at 0, which is the middle point on the sinusoidal axis. The next one is at the highest point. Then we have middle point, then low, then middle. So we had low here and the middle here. So this will be the first cycle of this graph. Then the second cycle goes from here. Again, we had middle. After middle, we have high, then middle, then low, and then middle. And this will be the second cycle of this graph. Okay, let's do the next one. Over here, we have y equal to 12, 3 over 4 sine of theta. So by looking at this function, this is the a value, and this one will be the b value of the function. So a value gives us the amplitude, which is 12, and b value will change the period. So the period of the function will be 360, which is the period of the parent function, divided by 3 over 4. And we know that if we want to divide fractions, we need to take the first one and flip the second one, 4 times 4 over 3. So I can simplify. 3 by 3 is 1, 360 by 3 is 120, and that multiplied by 4 is 480. So this is the period of the function. Then we need to find the distance between the critical points by dividing the period, the new period, by 4. And that will be 120. So to graph the function, I'm going to start with the coordinate plane. Then the critical points starts with 0, and then the steps between the critical points are 120. So this will be 120. Another 120 added to this is 240. Another 120 to this will be 360, plus 120 will be 480. Well, this is now one period of this function. Now the second period, I'm going to draw that with another color. Again, we're going to add 120. So this will be 600, plus 120 will be 720, plus 120, that will be 840, and then another 820, so 120 to this will be 960. So this is another cycle actually. Then we know that the amplitude is 12, so we go 12 up. Let's say this is 12, and 12 down from the sinusoidal axis. And then this is cosine. We know that cosine looks like this. Starts with a high point, middle, low, middle, high. So we use the same pattern actually. So the first point is at the high point, then we have middle, then low, middle, and high. So this is one period of this graph. Then for the second again, we have the high point. After that will be a middle point, then low point, middle, and high. And this will be the second cycle of this function. I'm going to do one more for you, which is done with radian. For this one again, 3 is the a value and pi over 4 is the b value. So amplitude of the function is 3. Just simply we take this as the amplitude. And then b value is pi over 4. So to find the period of the function, we take the period of the parent function, which is 2 pi. Because we are working with radian, we write it as 2 pi. And then divide that by pi over 4. This means we are taking 2 pi and multiplying that by reciprocal of pi over 4. Now we simplify that. The pi can cancel each other, and this will be 2 times 4, which is 8. So this is the period of the function. To find the critical points, we take the period and divide that by 4, which is 2. So these are the steps or the distance between the critical points. Now I'm going to graph the function. The first critical point is 0. The next one is going to be 2 because we add 2 to that. The steps between the critical points is 2. So this is 2, then we have 4, 6, and 8. This is one cycle, and then the second cycle will be 10, 12, 14, and 16. The amplitude is 3, so we go 3 up and 3 down. Then this is sine, so starts with middle, high, middle, low, and middle. So we use the same pattern. Middle, high, middle, low, middle. This is the first cycle, and then the second one again, middle, high, middle, low, and middle. So this is the second cycle. I'm going to leave the rest of the problems for you to do. Hopefully this was helpful for you. Have a great day.